All right, remember that the denominator of a fraction cannot be 0, so we're going to set the bottom equal to 0 and solve. So I have x minus 2 equals 0. X cannot be 2. So in interval notation, it's negative infinity to 2 and 2 to infinity. For number 2, we have to factor first if it isn't factored. So the two things x cannot be are plus or minus 6. So we write that as negative infinity to the smaller number, the two numbers together, and then the bigger number to positive infinity. Now when you have a plus an x squared, remember that there's no way to factor that, so my answer would be all real numbers, which is negative infinity to positive infinity. For numbers 4, use the graph of rational function to show the complete statement. So as x approaches negative 2 from the left, remember that the negative sign means from the left, and that negative sign I'm talking about is this little one right here, that minus sign. The plus sign means from the right. So if we go back to where we were, negative 2 from the left, we'd be going towards negative infinity. 1 from the right is going to be negative infinity as well. And then x approaches infinity, y approaches 0. As we approach 1 from the left, here's 1, here's the left. So that would be positive infinity. As x approaches negative infinity, y is approaching 0, and negative 2 from the right is positive infinity. All right, so graph the rational function. Remember, for domain, you set the bottom equal to 0, so x cannot be 4, negative 4. My horizontal asymptote, you set the first number on top over the first number on bottom. For the vertical asymptote, you set the bottom equal to 0. For x-intercept, you set the top equal to 0 and solve. And for y-intercept, you fill in 0 for x and solve. So for my domain, I get negative 4, okay, which is my vertical asymptote, so that's going to go here. My horizontal asymptote goes at 2. And then the point 0, 0 goes here. So I know that this graph has to go below that asymptote. Now I need a graph on the left-hand side of my vertical asymptote, so I'm going to plug in negative 5 into the equation. So 2 times negative 5 over negative 5 plus 4 is negative 10 over negative 1, which is positive 10. So when I plot that point, negative 5, 10, that makes that graph go that way. For 12, my domain, I'm going to factor that bottom, x plus 2 times x minus 2. So x cannot be plus or minus 2. My horizontal asymptote, my indexes are the same, or my highest exponent. So y equals 2 over 1, which is 2. My vertical asymptote, we're going to have 2 here, plus and minus 2. My x-intercept is 0, 0 by setting the top equal to 0. And my y-intercept is also 0, 0 by filling in 0 for x. So my horizontal asymptote is at 2. My two vertical asymptotes are at negative 2 and positive 2. And my 1, 0, 0 goes there, so we're going to have this guy come right here. I'm going to pick 2 points, one to the left, so negative 3. So 2 times negative 3 squared over negative 3 squared minus 4. So that's 18 over 5. So that is definitely over 2. So that's going to be here. And because both of the x's are squared, when I pick positive 3, I get the same y value. Coming over to number 12, we're going to factor that bottom first. So it's 4 over x plus 2 and x plus 2. So my horizontal asymptote is top is less than the bottom, so y equals 0. My vertical asymptote is at negative 2. My x-intercept, there's no way to set the top equal to 0. And then my y-intercept, when I fill in 0 for x, I get 4 over 4, which is 1. So I'm going to go ahead and fill in those asymptotes, 1 at y equals 0 and 1 at x equals negative 2. I'm going to fill in my y-intercept, which is at 0, 1, which tells me that this graph goes above the line. Now I need a graph to the left of this, so I'm going to plot negative 3 into that equation and see what happens. So that gives me 4 over 9 minus 12 plus 4, which is 4 over 1. So when I plot negative 3, it's also up here as well. For number 13, for first step is to factor that bottom. Okay, I'm going to factor the top too. So my domain x cannot be negative 1 or positive 1. When I factor the bottom, I'm going to have to, hold on, it's x minus 1. All right, so my horizontal asymptote, I set the first number I see on top over the first number I see on bottom, which is 1. My vertical asymptote, x equals plus or minus 1. My x-intercept, I set the top equal to 0 and solve. I got x equals negative 5 and positive 6. For my y-intercept, it's 0, 30. That's really high. It's going to be hard to show that, so we're not going to really be able to do that. So my horizontal asymptote is at 1. My vertical asymptotes are at plus and minus 1, right here and right here. Now that x-intercept, we have 2 of them, one at negative 5 and one at positive 6. So this is going to go this way, and this is going to go this way. My y-intercept is 0, 30. So this guy is just going to look like that, but way higher. All right, so now on to 14. Solve and graph. Remember that we factor first. It's x minus 7 and x plus 2. I set both of those equal to 0. I'm going to plot both of those, negative 2 and 7. I'm going to pick 0 because it's in the middle and see if it works. So, is negative 14 less than or equal to 0? Yes, it is. So I'm going to shade in between. And I'm going to write it as interval notation, bracket, negative 2, 7. Why am I using brackets and not parentheses? Because of this little guy right here, which is this. Whew. That little greater than or equal to sign makes it possible for there to be brackets. For number 15, I'm going to go ahead and factor. So I take an x out. Oops, excuse me. Sorry, guys. No. Oh no, something just terrible happened. Okay, I'm back. So we take an x out. We have 11x minus 5 left over, so x equals 0 and x equals 5 over 11. So this time it's hard to pick 0 because you can't. So I'll pick 1 and see if 1 works, and then we'll go from there. So when I fill in 1, I get 11 times 1 squared minus 5 times 1 should be less than 0. Because it did not work, we're going to shade in between because 1 was not in between our two numbers. For number 16, we start off by cutting it in half. We can take an x squared out. We have an x plus 9, a negative 1, and x plus 9. So x squared minus 1 and x plus 9. This can still be factored to be x plus 1 and x minus 1 times x plus 9. X equals plus or minus 1 and negative 9. So remember that trick. I know it's been a while, but the every other trick. So 0 is right in the middle of negative 1 and positive 1. That's what I'm going to pick first. When I fill in 0, that should be greater than 0. It is not. So 0 didn't work. So that tells me that this is going to work and these two are going to work. Remember, it's every other one. So that would be negative infinity to negative 1 and 1 to 9. For fractions, I love these guys because it's just easy. You set the top equal to 0 and the bottom equal to 0. So x equals 6 and negative 5. So we're going to go ahead and put those on, negative 5 and 6. I'm going to pick a number in between. So 0 minus 6 over 0 plus 5 should be greater than 0, not 6. So it is not. So I'm going to go ahead and shade the outsides. So negative infinity to negative 5, and 6 to infinity. Number 17, I'm going to go ahead and set everything equal to 0 and solve. So my three things are negative 6, 3, and 1. So I'm going to come over here. Whoops, sorry guys. We're going to put that on. Negative 6, 3. Sorry, that should be a 1. And 3. So now I'm going to go ahead and I am going to pick 0, which happens to be in between negative 6 and 1. So 0 plus 6 times 0 minus 3 over 0 minus 1 should be greater than or equal to 0. So we get negative 18 over negative 1 is greater than or equal to 0. So this guy's going to work and this guy's going to work. So that's negative 6 to 1 and 3 to infinity. 18, I'm going to minus the 2 first, so x over x plus 4 minus 2 is greater than or equal to 0. I'm going to put a 1 underneath and get common denominators. So now on the top I have x minus 2 times x plus 4 over x plus 4 is greater than or equal to 0. That becomes x minus 2x minus 8 over x plus 4 is greater than or equal to 0. So that's negative x minus 8 over x plus 4 is greater than or equal to 0. So when I solve that, I get x equals negative 8 and negative 4. Now this time 0 doesn't lie in between, but I'm still going to pick him because I want to see if he works. So I get 0 over 0 is not greater, so 0 does not work. So here we're going to plot in between. All right. So 19, I'm sorry. Y varies directly as x. So y varies, you write equals k. Directly means to multiply, and inversely as the square of z. So now I'm going to fill in everything. So 60 equals k times 45 over 3 squared. So that gives me 60 equals k times 45 over 9. So 60 equals 5k. So k is going to be 12. So now I'm going to plug that 12 in. So find y. So y equals 12 when x is 25 and z is 2. So y equals 75. Y varies, so y equals k jointly as q squared and h. So well, this one can't be done, so we'll move on to the next one. All right, let's keep moving on. Numero 21. Now remember, you have to list the factors of the last, so that's 1 times 6 and 2 times 3 over factors of the first. So now we're going to plug those in. Let's try 1. 1 plus 2 is 3. 3 minus 5 is nope. Negative 1 plus 2 is negative. Yep, negative 1 is our first one that works. How do we know it works? Well, it equals 0 when we plug in the possibility. So we're going to write x equals down here, negative 1 as our first choice, and we're going to start our synthetic division with that. So there's nobody missing. So we're going to go ahead and bring down our first number, multiply by the negative 1, add, we get 1, negative 1, negative 6. So this equation is x squared plus x minus 6 equals 0 because that's your remainder, constant x and x squared. So when I factor this, I get x plus 3 times x minus 2. X equals negative 3 and 2. Add that to the negative 1 that we started out with. For number 22, again, we find factors of last. 1 times 20, 2 and 10, 4 and 5, over factors of first, which is 1. 1 plus 8, 1 works. So our